Hello everyone. So, all right, we're live. Hello everyone. Oops. So, all right, we're live. One sec, technical issues. All right. And cool. Two viewers. Cool. So, anybody who's watching, let me know if you have any questions as I go through this. So yesterday we were working on ConduitSQS, which is an adapter for SQS for the conduit library. We can go through the architecture again real quick. So essentially conduit requires an adapter to do three things. One is accept essentially a topology, which allows you to say I want you to create these queues, and if it's supported, exchanges as well. It needs to accept subscribers, and then the adapter is responsible for basically setting up those subscribers and listening for messages, and then handing them off to Conduit whenever they come in. And then the final piece is Conduit expects the adapter to have a publish function, so that whenever your application wants to publish something, Conduit can hand that off to the adapter, and the adapter will handle sending that wherever it needs to go. So yesterday, when we were working on this, we built part of the supervision tree. So we built the ConduitSQS supervisor setup, which created the queues for SQS. We created the polar supervisor, the worker group supervisor, and we also implemented the publish function for ConduitSQS. So today, we've got essentially these three pieces left, plus this line here. So the polar here, its role is to basically keep checking SQS to see if there is anything new since it last checked, any new messages that it wants to send off to one of your subscribers. The worker is responsible for actually doing the work to that message, and there can be many workers to a polar. So you might be listening to a queue called, I don't know, send email. And you may have many workers that are consuming from that polar to send emails. So the worker supervisor is going to be supervising all of the workers that are consuming from the polar for send emails. The worker group supervisor is going to be supervising each of those groups of workers. So for example, you might have a queue called send email and a queue called, I don't know, create user. And so each of those would have their own worker supervisor, but each of those would be nested underneath the worker group supervisor. And so that way, if you have a worker that's a little flaky for sending email, if that crashes, that's going to crash this supervisor, and so that's going to restart, and it's not going to crash other workers that are also doing work, but for a different queue that may be a little bit more reliable. If that work does become super unreliable, it will cascade up and crash this supervisor, and further up crash this supervisor. But that's basically just if nothing's working at all. So generally, we're trying to isolate the types of failure that we'll have, and have something basically handling the restart of those similar types of errors. So that's what the worker supervisor is going to be providing for us. So the first part we're going to start working on today is this polar. So in order to do this, we're actually going to start with the polar supervisor, though, to make sure that it actually starts processing that. Cool. So let's close all this. And let's look at the polar supervisor. So right now it has no children. But we have these subscribers here that basically describe all of the queues that we're going to want to listen to. And this is a, I forget what this is. I feel like this is a map of name to queue. Let's just double check that. So in our ConduitSQS test, we started to set this up. So for a polar supervisor, we're passing in a list of maps with a name for a subscriber and a list of queues in the from. Alright, so we only care about this from part for the polars, because we're going to have one subscriber, one polar per queue. So let's set that up. Let's take this actually. Let's create a test. So this is going to be the polar supervisor test. So ConduitSQS polar supervisor test. We're going to use XUnit case. So this one can be async because we're not going to do anything special here that might require shared state. And we're going to describe, let's see, so polar supervisor. We're interested in describing what this init does. So we're going to pass in the options that we expect. And then we're going to assert that it returns the child specs that we want. So back to the test. So we're going to describe init 1, do, and so test returns child specs for each queue. All right. So what we can do here now is we can just call, actually let's alias that real quick. So let's alias conduit SQS polar supervisor. So here we're just going to call init. And then we want to pass in all the arguments. So init is sort of special because of the way that it gets called. Because it's part of GenServer, and supervisor. They want a consistent interface to pass arguments. And so what that means is that they need to know how many arguments to pass. So they always just pass one argument, which is a list of the arguments. And so that's why you see here I'm doing a init, giving it a list, and then giving it arguments. All right, so let's actually just take this guy here, which will be our list of arguments that's getting passed to our test. Cool, and actually let's pull this out into module attribute. So let's call this args. All right, so 2 arguments here. One's that list. All right, one is that map and one is a list. So we have a map. Let's split that out too. So a map to a tuple with a subscriber and its options. So we really care about these options here. So let's pass at args here. And let's do child's. So this isn't exactly child specs. It returns a couple things. So returns the child specs, the supervisor's options, and then its child specs. So let's match that. So we can do assert, and then the pattern match. So the adapter ops will be pretty similar to the parent one. We're just going to do a one-for-one supervision strategy. And yeah. So let's see. So let's do adapter ops equals. So it's going to be pretty similar to this. Right, so it returns the strategy for restarting the children, max restarts, and max seconds. So that's what these 2 numbers are here. Next, we want to assert the child specs, just like we're doing here. Assert child specs equals, that's going to be a list. And we're going to leave that empty for now because we'll get a failure. So let's run the test. Oh, we passed. All right, so right now, this guy is returning an empty list. So the child specs are expected to be empty. So that's why we passed. Let's cause this to fail though. So we want, we're getting passed in this set of stuff, and we want to basically turn it into just a list of stuff from froms. So we can do that by, let's actually just copy this right now so we can have an example. All right. So let's see. We want to enumerate over the map. So here, subscribers, and the arguments there are going to be the key, which we don't care about. So we'll just call that name. And then we're going to get a tuple of subscriber and ops. So ops is what we care about here. All right. So in the options, we should have a from. So we're just going to pull out from that keyword list, and then so that's going to be a list. So we essentially mapped to a set of lists. We can turn this into a pipeline. So now we have a list of lists, and we can just use enum.flatten. Oh, I guess we could just use flat map actually. So now we have a list of queue names basically. But we also want to pull out all of the other options that we can use for creating a map. So what we're going to do is actually, you know what? Oh, yeah. So we're going to map this to a tuple. So we'll have from and then just ops itself. So that means that, oh, actually we'll want to flatten that though, because that'll be a list there. So let's just do this. Let's do enum the map ops from, and then we can do ampersand tuple. So this will just create an anonymous function where we can do ampersand1. So that'll be one of the froms, and then we can just put ops in the other part of that tuple. Cool. And then we're flat mapping that. So this will create a list of tuples. This will then create a list of tuples. So and then we'll flatten that out. So we'll just have a list of tuples. All right. Now we want to turn that into our children that we're passing in here. So let's just do children equals that, and then we can map that into a child spec. So here we're going to get a queue and its ops. And what we're interested in getting eventually is a child spec. Let's just that's not what I want. ConduitSQS. So we're basically going to be creating workers. This will be, well, let's just copy this right now. So we're going to create a worker here. So here we're going to be creating a polar though. And that polar is going to have a queue and ops. And shouldn't be restart transient here, because we want that to basically always be restarted if it fails. Cool. So now we should have child specs. We do need to give these names since we're going to be using the same module. So we can just do, how do you get an index? I think there's an enum. So we want to do name here, name colon, and then we give it a name, which will just be the name of the module that we're going to be using. And then we'll just give this a number. I forget what the enum method is that gives you an index. Let's just go check that real quick. I'm pretty sure it's called like with index, something like that. Yeah. Right, so we can basically take what we generated with the map and then just call with index, and that'll give us key value pairs of our value and then the index, and then we can iterate over that. So we can do that right here. We can turn that into an enum with index. So now this is our key, and we'll have the index as an argument. And this should be a tuple. Cool. So now we can just plop an index here, and that'll give each of them a unique name. Oh, we've got a comma there. We don't need that. All right, so let's run our tests. Maybe something will fail. Cool. So looks like I didn't screw up. That's good. Let's see. Wait. Yeah. So this is just the child specs. So we're going to fix this test, but then we're also going to make it a little bit more complex. We want to see if we handled some more complex cases. So let's look at the Polar supervisor. This is the child spec that we've generated. We're going to break this up. So let's break it here. And let's break it here. So this is saying that we're going to start this process. In order to start this process, it's going to start this module, call this function, and pass these arguments to it. And then these are the options for running that process. Wait, where's our name flag? I might have messed that part up. I'm pretty sure worker takes a name option. ID, that's what I want to pass, not name. This is just so that the supervisor itself can tell the difference between each of the child processes. So basically, if this one crashes, if they all had the same name, it wouldn't know which one was the one that crashed. So it wouldn't know to restart that specific one. So giving them a unique ID allows the supervisor to better handle that situation. All right, so let's run that. And now we have fixed. So that was actually the ID, that first argument there. So we've now broken the test by fixing our issue. So let's turn this into a tuple and get that in a hexa 1. Cool. So now if we rerun that, we should be good. Oh, right, index starts at 0. Okay, so let's actually get this to have couple more. So let's just name it test 2. It's going to just subscribe to ConduitSQS test 2, and we're also going to have it subscribe to test 3. Alright, so yeah, so that looks good. Oops. Syntax error, polar test 9. We forgot a couple. Okay, so our first child spec is fine, but we also generated 2 more now because of the new option and the multiple froms here. So this would be 1, 2, 3. So let's go to our test here. We can add what we missed. I'll go break these up at the same spots. Cool. Now if we run our tests, we should be set. Cool. So let's go ahead and commit that. Alright, so the next bit is that we're going to actually create the polar. So this is going to be a GenState producer. So I'm going to need to actually pull that in. I haven't pulled in that dependency yet. So let's go to hex. Just look to see what's new. So we want 0.12.2. So let's go to mix and add that as a dependency. That's good. Cool. So now let's do mix steps get. Let's pull in our dependencies. Cool. And let's also do mix compile just so that my editor will autocomplete. We have unused options, polar supervisor X and worker group supervisor. So this one's sort of expected. This one, I'm not expecting that. Let's just double check that. So it says we're not using, yeah. So let's call this subscriber ops. Well, for this window here, we'll call it ops, but here we'll call it subscriber ops. Because we're also going to want to pass these top level options here. So these are the adapter options, and these are things specific to that particular subscriber. Cool. So that's going to change. Yeah, so let's rerun our test because that's going to break our test now that we're passing an additional option. So we just need to add this guy to list of ops. And we should have passed in tests again. So at the end here, basically after the dark blue. Alright, now we're passing again. That looks better, and we don't have those failures. Alright, so now deploying in GenState. So let's just look at the docs a little bit. It's not showing them. Alright, let's go to the online documentation. So, we're going to define GenStage. Our GenStage is going to be a producer. And we're going to want to pass down our options. And we're going to need to define a hand command. Alright, so let's just start with this stuff. So we're going to start this module. And so this is going to be our arguments, which are going to get passed here. So these are the things we were just looking at in this test here. So it's going to be queue name and subscriber options, and then options for the adapter. So queue we're just going to pass those through like so. So it's going to be queue subscriber ops and adapter ops like so. And so now init is expecting us to basically return the type of GenStage that this is, so it's going to be a producer. And then it wants us to store the state, and so that'll get passed to us on each of our callbacks. So I like to just define a struct called state underneath each of my my gen servers that actually store something. So we're gonna just name these the same thing. So it's gonna have a queue, subscriber ops, and adapter ops. Cool. So now we can create state here and just list out those things. So we'll have queue, subscriber ops, and adapter adapter-ops. Cool. So we can go ahead and start testing this. So we're going to do a polar test. Yeah, def module. There we go. So this will be ConduitSQS polar test. So we're going to set this up so that we can do these tests asynchronously. So we're going to use xunit case async true. So the situation where we wouldn't want to set this async to true is if if we were actually making a request to SQS here. But I'm going to put that somewhere else, and I'm going to allow that to get swapped out so that this test can be basically completely async. It doesn't need to have that dependency from some outside resource. So here we're going to describe init, and we're going to test it sets itself as a producer and stores its state. Cool. So let's go ahead and alias that. Alright, so now we can just call it polar.init, and we want to pass it our arguments. So the first thing is going to be the queue. So let's actually do it like this. So we're going to pass in the queue, and subscriber ops and adapter ops. One sec. All right, so I've set up the queue. So let's define these variables. So queue. So we'll just give that a name. It would just be conduit SQS test. Subscriber ops. So here we're just going to pass an empty list. And then adapter ops. We're going to do the same thing. So now we can just assert that this is exactly equal to tuple with producer and I don't like how that breaks up. Well, so let's just do it. So polar state and then we should have Q. So we don't need to pin it because we're doing a equals comparison, not a pattern match. Cool. So if we run our test now, we should expect that to pass, I believe. Fail. Subscriber ops not found in adapter ops queue. We misspelled subscriber ops. Whoa. I believe this means I'm using too much memory. All right. One sec. Let's just make sure that. Yeah. So the screen recording stuff is taking up a lot of CPU right now, and so that sometimes makes this act a little wonky, but it should come back. All right, there we go. So I misspelled subscriber ops. So now if we rerun our tests, should not get a misspelling error. Cool. So now, so there's one other thing we want to do here. So init allows you to pass the type, the state, and then as a final argument in the tuple, you can pass options. And one of the options we want to pass is an option to tell it not to actually start sending demand to the poller. So the setup is going to be that setup, the process, is going to run and create all the queues. It's then going to tell the poller, hey, you can actually start accepting demand now. So poller starts not accepting demand, and then setup will set up something to allow it to know that it should then start accepting demand. So I need to check what that option is though. Okay, so the init callback. We can do producer and where is it? There we go. So the option we want to pass is demand. So when forward, demand is always forward to handle demand. We want to set it to accumulate. That way, GenState will handle essentially accumulating those messages for us until we're ready to actually start processing them. So we can do demand accumulate. Let's just look at the callback print. Yeah, so we're doing this one, which is type, producer, state, and then options. Let's So that was one of the init options. All right, so we rerun our tests. We should get failure now because we're not checking for that option. So we can just add that. Not there, inside of our pull test. I'll go ahead and wrap this too. So we run our tests again, and everything's green. So let's go ahead and check this in. OBS is really chewing through CPU right now. Alright, so the next thing we want to do is define the handle demand callback. Oh, sorry, that's not the right one. Oh, no, yeah, no, it is. Not the demand function, the handle demand callback. So this accepts two arguments, demand, which will be a number, and state, which will be the state that we passed back from our init. So let's go ahead and describe that. All right, so the first test we're going to do is, let's see. Actually, so one thing we want to do is inside of our polar, we're going to want to keep track of the current demand. So we'll go call that demand, and we're going to initialize that to 0. So that's going to break our tests. Oops. So we're going to rerun. Oh, it didn't break our test. Oh, we're just not checking for that. Oh, actually, so since state defaults to demand 0, it's already there as part of the tuple, and that's why it didn't fail. Let's actually just get rid of it then. Alright, so we're going to define a handle demand function. So this is overriding a callback. Actually, we can use the override. I don't remember what it's called, so I'm not going to use it yet. But you can basically say that your function is an implementation of a callback. And so since we're using GenState here, which is a behavior, we can basically say that we are implementing a callback provided by GenState. Oh, I remember what it is. It's just at impl true. We can do that for this one as well. So we should get here our new demand. And our current state. State. And we can get demand out of here and call that current demand. So what we want to do so actually let's do the case where this is 0. So in the case where we have we previously had no demand, we're going to assume that we were in a state where we weren't actively polling anything from SQS. The reason we're going to do that is that essentially if nobody's able to consume the work that we would do, we just basically completely shut down the poller and don't do any consumption until somebody's actively ready. So the case where demand is 0 means that we actually want to start up something to actually handle that new demand. So let's do demand. Well, so our new demand is basically the demand. We're going to send ourselves a message though. So send self. So our message is going to be poll for messages. And actually, let's just call it get messages. And then here we just need to pass our options, so we don't have any. So, all right. So that's going to send ourselves a message in the future whenever we are starting to have demand after not having any. Cool. And now we want to return from this our new state, which will just be our old state. Oops. Our old state with demand updated to be the new demand. And then, is there? Oh, let's just check the docs. I don't recall. Okay, so we need to respond with no reply, a list of events, and new state. So we don't have any events yet because we're not buffering anything. We're going to go out to SQS to actually pull those. So here we're just going to return an empty set. Cool. So the next case we want to handle is basically if so we've handled the case where demand was 0. We now want to handle the case where demand is something greater than 0. So in that case, we can sort of assume that we're already polling for messages. So we basically just want to calculate new demand and set that as our new state. So let's do new demand. demand, current demand, and then equals state. And then we can just do a no reply. Empty events again, because we're going to pull those separately. And then we're going to update our current state with the demand of new demand plus current demand. Cool. So let's test that out. So where's that polar test? All right. So here we're testing when there is already demand, it adds the new demand to the current demand. Cool. So here we want the polar state. Since we're not actually using any of the other things here, though, we can just ignore them for now. So we're just going to set demand equals 1. So that's our state. And now we can do assert polar dot handle demand, and we're going to pass in our new demand. Let's say it's 2, and our state, and we expect to get back a no reply. Empty set of events, and a new state. So let's do, let's just define our own new state with 3 as our new demand. And then we want to do one other thing, which is, in the one case we send ourselves a message. In this case, we should not send ourselves a message. So we want to do a refute received, and then the message will just be get messages. Oops. Cool. So if we run our test here, I did no underscore reply instead of no reply one word. Cool. So that test passes. So now we want to test the other case where our demand is 0, which means that we're not actively doing any work right now. So when there is no demand, it sets the new demand and schedules the polar. So we can basically do everything here. We'll get similar results. So let's just call this 3 here, so that we don't have to change that. And then we want to assert that we actually receive this message now. So when we run that, we get a failure, of course. Oh, we forgot to set this to 0. I like to say we, so it's clear that it's not my fault. So let's go ahead and check that in. What's this doing? We are handle demand for Polar. Cool. So now let's tackle get messages and what that should do. So if we go down here, whenever we send a gen server message directly using process.send, it always goes into handle info. So we'll get past the message, which will be get messages, and the current state. I'm not sure what we want from that yet, so we'll just do that. Alright, so I want this to run something to actually get the state. So that thing will be, let's alias it here for now. Alias ConduitSQS .SQS. So we want to be able to say SQS get messages, and we're going to pass in the queue, the subscriber ops, and the adapter ops. So that's all that stuff. So we're actually going to pull all that out from here. So don't care about the queue. I'm going to shorten this just because we're only pulling them out to pass them in here. So let's do sub ops, dap ops. Whenever I do pattern matching and it starts to get too long, especially in a function signature, I reconsider my choices. So here, I kind of don't want to do this just because it's getting so long. So I'm going to do just that one, and then do these directly off state. So we can just do a state, subscriber ops, and then state adapter ops. So that's going to give us some messages. So this might actually fail. The question is, do we want it to crash this process or not? For now, I'm going to say that's okay, but may revisit that in the future. So this is going to give us some messages. So here we can actually send those messages to GenState to distribute. So to do that, we just need to do no reply, messages, and the new state. So the new state should be the old state. Let's pull out demand here, actually. So the new state will be the old state with demand updated to be the current demand minus length of messages. And I think that's all I need here. Let's just double check handle info. Yeah, so we're doing this one. So that looks good. So now, so I mentioned before that this test is going to be async, but it can't be async very easily if it's making a call out to SQS. So we're actually going to set up something so that we can swap that out for our test. So I like to use this library that I wrote called injects. So it gives us a function called inject, where we can give it a name. So here it will just be SQS. And then a module that we want it to return. So basically behind the scenes, this just defines a function that returns this module. In test, it does something a little more complex. It defines a function that looks up in your application config what module to use. And if no module is specified there, then it just returns this one. But that's only a test, so in dev and production, it's a straight pass-through to just return this module. So now we can call that function, SQS, and then we can call get messages on that. So that's going to allow us to override it in our test. All right, so we're going to describe handle info to all right, so we want to test there's another case here. Basically we want to handle if the demand is getting down to 0. We want to stop scheduling messages. But if our demand is above 0, we want to keep scheduling get messages. But we don't want to do that immediately after. We want to put some delay in there so that we can handle that. I'm going to stop right here briefly and take a break. But I should be back, let's say, at least by 8, probably by 7:50. All right. So what we did right before the break, we defined this handle info callback, which is going to get messages. So it's actually going to call a method called get messages on SQS. It's going to then reply with the messages and the new state. So let's just go ahead and add a test for that. So let's say that differently. So from the outside, it looks like handle info is producing new messages and updating the demand. Oops. Sparse subscribers. All right. So let's test that out. So let's define what our state is. So we can use sort of a mock state for most of this. So we want to define a polar, and its Q is going to be ConduitSQS test. Its subscriber ops are going to just be an empty list, and its adapter ops are going to be an empty list, and we're going to set the demand equal to 10. So that's our state. Now we can assert that our polar, and we call handle handle message, no, handle info with get messages, and we pass in the state. It should return a tuple, oops, with no reply. Some messages, and we'll have to get those to be real messages in just a second. Actually, let's make it fail. So let's do a message here. And then it'll return a new state, which will look exactly like the old state, with the demand being 2 less because we're going to generate 2 messages there. Okay, so this will theoretically work, but it won't work exactly yet because that ConduitSQS module is going to get called unless we do something to fix that. So here we can use override, and we can specify the module who has a function that we want to override. And so here that's going to be polar. And the function we want to override is SQS. And the thing we want to override it with is our essentially our mock module for SQS. So we're going to call this SQS 2 to just say that it's going to return 2 messages. And we can do we can do all of this inside of a block. So now we've overridden Polar's SQS function to return this module. So we need to find this here in the test. So we're just going to do that right here above the test. SQS2. Let's make this. Let's just make it 5. That way we might not actually need to override it or define multiple. So let's define a function which is get messages. Oops. Get messages. Let's just go take a queue, subscriber ops, and adapter ops, like so. Oops. And since this is a mock, we're going to have this send message to the current process. So we're just going to send self, and then a tuple with get messages, and then each of these things. And then we're going to have this return just 5 conduit messages. So we can do that by just doing and then .map dot 5, and then we can do a function it's going to get past the number, and then here we can just do a new conduit message. So we do that, and that produces 5 messages. We should have 5 messages here. And our demand is going to go down to 5 from 10. So let's run that test, see what fails. Alright, Mr. Terminator. Polar 36. So we close the map, we didn't close the tuple. A new error. Oh, this should be an inject. And now we got let's see. So since we added impl true to these guys, it's telling us, hey, we forgot to do it for this one. Alright, so thinks that we're trying to build a struct at polar test 46. Polar test 46. Right, we want this to be a state. Same thing here. Message struct is undefined. let's alias that so we don't have to do that everywhere. Cool. So we can actually get rid of this. And override is undefined. Right. So in the test, we need to import injects test. And that should give us that function. And now we're good. Alright. So we asserted that we get the new state. So one thing we should expect though is that we're also going, so since the demand hasn't gone down to 0, we want to pull new messages. Whenever we pull messages with the get messages from SQS, that's going to pull a lot of messages. Like we're going to try and pull as many as we can that at least sort of fit the demand. But if we actually no, we should pass the number of messages also to get messages. That's a side note. But we're also going to so say we have 100 demand and we want to pull 100 messages from SQS. So we tell SQS, hey, give us 100 messages. SQS gives us 50 messages. So our demand goes to 50, but that also means that SQS didn't have 100 messages to give us. So if we immediately schedule get messages to happen right after we made that call for all the messages we wanted, then that means that SQS is likely to return nothing again. So that's a little problematic. So we want to build in some delay there in the situation where we requested some number and we didn't actually get that number. If we requested that number and we got that number, we can schedule again immediately as long as there's demand for it. Because we know that SQS at least had the demand that we wanted, and they may have more. Sorry, that's a little bit different. So we may have a demand of, let's say, 200, but we may only request 100 at a time. So if we get back 100, then that might mean that SQS has 100 more, or some number in between there, something greater than 100. So we want to do it again immediately so that we can get that set of messages too, if that's how big our demand is. So we're going to try and replicate some of those scenarios. So let's see. We want to pass in the demand, and we also want to control how many are fetched at a time. So for that, we're going to use the subscriber opt. So let's pass in here fetch limit. And we're going to call that let's see. We're going to say that's 5 here. and I'm just thinking about how I want to set this up. If I want to have essentially multiple mocks here. Let's rename this SQS equal, and when it's equal, it's going to always return however much the fetch limit is, and then we'll have one for less. So we'll just like subtract 2 from whatever the fetch limit is, and then and then we should test getting down to 0, so where the demand is actually just 5. Alright, so let's do that. So here we're gonna do subscriber ops. Fetch limit. So if we run this now, that should pass. Or not. Let's build subscriber. Oh, just calling it SQS5 here. Fix that. Right, so we have a new option that we just need to mention in here. Cool. All right. So let's just play out that logic. So I'm going to do first I want to pass the demand here. Well, I want to pass the larger of no, the smaller of. Sorry. The minimum of the limit, fetch limit. So let's do fetch limit equals keyword dot fetch. And then we're going to do subscriber ops, fetch limit, and then we're going to give this a default. I don't know what reasonable for SQS. I'm just going to make that 100 for now. So then so fetch amount is going to be the min of fetch limit and the current demand. So let's pass that in as an arg. Let's do it here. So fetch amount. So so now we can calculate the new demand after we run this. So the new demand equals the current demand minus length of the messages. So that we can just pass through here. So now we want to check a couple cases. So the first case we want to check is, let's do it like this. So did our demand go down to 0? So is the new demand, I'm saying mu demand instead of new demand. So if the new demand is equal to 0, then we want nothing to happen. We don't want to schedule a new get messages because there's no reason to. So that's sort of this state here. So if we do eventually get more demand, then we'll schedule get messages again. So the next state we want to handle is whenever new demand, so we know new demand is not 0, so that means that's greater than 0 because it can't be negative. So in the case that new demand is greater than 0, we're interested in knowing, actually, so we want to know how many messages we got. So let's pull that out. Let's call that handled demand. So when our handled demand is equal to the fetch limit, that's the situation where we pulled as many as we could get and there weren't any more for us to pull. We pulled as many as we could get and there may be more that we could pull. So in that situation, we want to send ourselves a message, self. Our message is get messages, and that's it there. So then the final case is we didn't use up all our demand. Wait, sorry, is that right? We had lots of demand. We only handled some of the less than the fetch limit of demand. So in that case, it probably means that SQS doesn't have anything for us to pick up. So we're going to send a message to the current process again with get messages. We're going to send it after some wait period. We're going to set that to 200 milliseconds for now, but we're going to make that configurable. So now, we have the situation where we handle all the demand. We have a situation where we handle the demand up to the fetch limit, and we have the situation in between those two. where we didn't quite reach the fetch limit, but we didn't handle all the demand. So now we can test those cases. So the first one is the easy one, because we don't do anything other than handle all the demand. So let's actually turn this one into that case. So if we just change this to 10, actually let's change some of these numbers. So let's make this a 5. Let's make demand also a 5, and then this should be a 0, and and this should be good. I should change the description for that test. Let's see, polar 35 subscriber ops. Polar 35 subscriber ops. That's, oh. We need to do state. So I haven't pulled that one up. Keyword fetch, not defined. Probably won't get. Okay, cool. So this is saying that get messages for is not defined. It's not defined because I added a new argument here. So we're going to call it fetch amount. Add that here. And this should actually be fetch amount. Cool. So now we have a passing test. We just want to change this text so that it reflects the current state. So when all demand is handled, it produces messages and updates demand. And we're going to define a test for when demand is equal to the fetch limit is handled. It produces messages, updates, demand, and schedules immediately. So we're going to copy this test. So we can define our demand to be a large number so that we don't consume all of it. We're going to use the equal equal mock so that it produces 5. And so now we can Actually, let's add an assertion here that so we want to refute that we received get messages. And no, we're not actually using this. Let's ditch that. We're actually just using the return value here. So we're going to refute that we received get messages. Here we're going to assert that. And since we're calling this in this process, it's all synchronous, so it will have absolutely scheduled this message by the time we make it to this point. So let's test that. We have some unused variables. That's because we're not using these here. Let's just underscore those. So now we should have passing test, no warnings. Alright, so now we have one more test that we need to write. And we might need a new mock also to make this happen. So when demand is less than the fetch limit, when demand less than the fetch limit is handled, so schedules later. This is a primary change here. So in order for us to get our demand handled less than the fetch limit, we need to set up that situation. So fetch limit's going to be 5. We're going to copy this guy. Call it less. So we're just going to do a fetch limit -2. So now, when we give it that fetch limit 5, it's going to return 3 messages. And the demand that's going to be left over will be 7. And so since we're using process.sendAfter, it's not actually going to put that message on the message queue for this process until that time is elapsed. So we're going to change this from assert received to assert receive. So it's going to wait. And we can tell it how long to wait. So we're going to say 300 milliseconds. So we schedule it for 200 milliseconds, and we wait to ensure that we got that message after 300 milliseconds. So we can run that, and we pass. Cool. So we seem to be doing all the things that we want to do there. All right. let's go ahead and commit this. So, actually, what do we do here? So we implemented the fetching of messages. The scheduling of message fetching. Okay. So get add check-in. Cool. Let's push that up. All right. I think I'm going to call it a night. I didn't see anyone actually join, but if anyone watches this on YouTube, thanks for watching. Bye.